Hi class, this is Dr. Karsten, and today we are doing Lesson 8 from Module 5, Grade 4 in Engage New York. And today's lesson is very similar to the last couple of lessons where we have been decomposing fractions to show equivalence. And equivalence, I don't know if you can hear it, but it sounds like the word equal. They're very similar. And when you have that equi, it often means that, that things are the same or have the same value. So today we are again going to be using models like we have been, and we are also going to be using multiplication to show equivalence between two fractions. Now, let me say that a few of you have been really confused about equivalence and equal fractions, and so I want to kind of show it to you in a slightly different way before we jump into the lesson, just to make sure that everybody is clear on how to do this. So, let's say that I have two tape diagrams and that they are the exact same size. So I'm going to do the best that I can to make these two tape diagrams the exact same size. That's pretty good. So now let's say that I'm going to cut them both into two pieces. And then I'm going to go ahead and I'm going to shade one of those pieces in both of them. So if we look at these now, we can clearly see that these two pieces have the same value. It's the same amount of the entire tape diagram. So let's go ahead and let's write what this fraction, what its value is. And this fraction's value is easy to figure out. Remember, the denominator is the number of pieces that make up one whole, or that one whole has been divided into the number of parts. So here I have two pieces, 1, 2. So that's my denominator. And the numerator is the number of pieces or parts that you have. Or another way of looking at it is the number of pieces that are shaded. And here I have one piece that is shaded. So I'm going to go ahead and I'm going to put a 1 up there. Now, let's say that I go ahead and I decide to cut this piece into two additional pieces so that I have a total of 4 pieces. 1, 2, 3, 4. I haven't changed the amount of the entire thing that's shaded. They're still the same. They still have the same value. But now the fraction is going to be different because, again, the denominator is the number of pieces that make up the entire thing. 1, 2, 3, 4. But in this case, 2 of them are shaded. So we just showed that 1/2 is the same thing as 2/4. This is what we've been doing in our lessons. The only difference is that this time I pulled the two pieces apart. I did it in two different drawings or tape diagrams. And I could write this. I could say that 1/2 is equal or equivalent to 2/4. Now, one thing that I've noticed is that for my students, it's often really helpful to use food to model this. So I do have a little something that I brought for us to use. And this is also going to be really quick. So here I have two heroes. So let's just look at the first hero. Now in this first hero, and actually I can slide it down so we're focusing more on that. So in this first hero, you can see that I have it cut into 3 pieces. I could share it with 2 of my friends and I'll have 1 piece. So these are thirds. I have 1, 2, 3. Each one is 1/3. But down here in my hero, I have it cut up into 6 pieces. 1, 2, 3, 4, 5, 6. So I think you can see all those. And what you can really clearly see here is that if I were to just take this piece and then these 2 pieces, they are the same part of the hero. They look exactly the same. This is 1/3, but these are 2/6, but you can see that they have the same value. So again, here what we just showed was, let me see if I can squeeze this in, is that 1/3 is equal to 2/6. Oop, not in the frame. There we go. Or, let's take a look at these pieces. Here I have 2/3. So let's see how many 6 they would be equal to or equivalent to. And there we go. We have 2/3 and we have 1, 2, 3, 4, 6. So now we just showed that 2/3 is equal to 4/6. I don't know if you guys can hear my dog in the background, but he just woke up. So I may have to pause and take him out really quick at some point during this video. Okay, so we have 2/3 are equal to 4/6. So now in this lesson, again, we are going to be modeling it with diagrams. We're going to be using area models like we've done in the last few lessons. And we're going to be decomposing them into smaller fractions, and then we are going to use the multiplication to show that. So let me go ahead and model a problem, and this is actually going to be the same exact problem as we have in problem 1B of the problem set, but you know how I don't really like jumping into it when they've already cut them all up for us. So let's go ahead and do that problem ourselves. You can kind of see it peeking through here. Let me grab us another piece of paper. Okay. So I'm going to quick draw what 1B looks like in the problem set. So we have an area model, and it has been split into 4 columns. And of those columns, 3 of them have been shaded in. And that's the original equation that we're working with, or, sorry, the original fraction that we're working with. So if I wanted to write the fraction for this, remember my denominator is going to be the number of pieces that make up the whole, 1, 2, 3, 4. And then my numerator is going to be the number of pieces I have, or the number that are shaded, 1, 2, 3. All right, so now in the problem, what we did was we were going to model turning that, I'm going to take my dog out. I will be right back. Sorry, guys. All right, and we're back. So, again, the original part of this fraction, the original fraction for this model is 3/4. Now, in problem 1B, they went ahead and they already had split this up or divided it up or decomposed it into smaller fractions. So let's take a look and see, after this has now been decomposed, what the value is of the shaded section. And if I were to look at that, I can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces or 12 parts that make up the whole thing. So I'm going to put a 12 in the denominator. And then the number of pieces that we have, or the number of shaded pieces, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So my numerator is going to be 9. But now the other thing that we have to do for this problem is that we have to show this with the multiplication sentence. Now we were doing that yesterday. So if I wanted to write this, the way that I would start it is I would say that 3/4 is equal to, I'm going to put where we're headed with this, which is 9/12. But now I have to show how I can change that. I have to show what we did here to do that. So I'm going to start by saying that I had 3/4, but I decomposed it by doing something, by multiplying it by something. And what did we multiply with? Well, I don't know if you remember our little trick. I mean, here we can just look and we say, oh, we cut them up into 3 pieces each. But that other little trick that we were using is that you can take either your numerator or your denominator. I'm just going to take the denominator. And I can say that 4 times a number is equal to 12 to figure out how we got there. So when I do that, I can also use the inverse operation. 12 divided by 4 is equal to that number. And when I do that, I should be able to figure out that the answer is 3 for all of these, which means that the answer down here is 3. Now again, the thing we learned yesterday was that if I want to keep the value the same, I have to really multiply by 1. And to multiply by 1, we remembered that certain fractions are equal to 1. And this was the whole lesson yesterday. If you don't remember this, you might want to go back. But the one thing that I will go over is to remind you that things like 2/2 is equal to 1, 3/3 is equal to 1, 100 hundredths is equal to 1. So as long as you have the same numerator and denominator, you know your value is 1. And that's because, let's say I cut an apple into 2 pieces, but I have both pieces, I still have the whole apple. If I cut an apple into 3 pieces and I have all 3 pieces, I still have a whole apple. So that's why when we multiply down here by 3, we know that we're also going to multiply by 3 on the top, because 3 over 3 is just multiplying by 1. When you multiply by 1, nothing changes. And we learned that again yesterday. So 3 times 3 is 9, 4 times 3 is 12, and now we've just proven that 3/4 is equal to 9/12. All right, class, you know what I always say. The first problem, it doesn't always make sense. By the third problem is when it all makes sense. So let's take a look at another problem. Let's jump into the problem set, and we're going to skip out of that problem number 1 because I am just not thrilled with it. Sorry, this is taking me a sec. So let's jump into problem number 2. Now, like I said, we just did this one, but we did it on the paper instead. And for homework, I'm not going to give you these. I would rather that you do it on your own. So let's jump into B. Ooh, sorry guys, I am very klutzy today. Okay, so for problem 2, it says decompose the shaded fractions into smaller units as given below. Express the equivalent fractions in a number sentence using multiplication. So it's basically going to be exactly what we just did. So let's go ahead and first figure out what was our original fraction. Now, you don't actually have to do this part for this problem. You could just write the fraction here, but I like to show what we're doing. So I'm going to go ahead and model it and write it down. So again, my denominator is the number of pieces that make up the whole, 1, 2, 3, 4, 5. And my numerator is the number of pieces we have, 1, 2, 3. So I know you can't really see that. So that says 3/5. So I'm going to go ahead and write that over here for us, so that we have a spot to do our number sentence. And now it says that we have to decompose into 15ths. So again, I'm going to go ahead and write where we're going to put our number sentence. And I know that I have to decompose it into 15ths. So I have to think 5 times what number is going to get me to 15. Remember, we're going to go ahead and show how we're making this happen. So 5 times some number is going to give me 15. If you can't figure out that in your head, what you can always do is say, oh, 15 divided by 5 will also give me that number I'm looking for. Well, hopefully you all know it's 3. So now I can go ahead and I can write that 3 here and a 3 here, because again, if I multiply by 1, I'm still maintaining the value of that. I'm going to go ahead and now model this. I have to now divide each one of these columns into 3 pieces. When you're cutting something up into 3 pieces, you're just going to cut it twice. So I'm going to put 2 lines going across. And now let's take a look and see if it worked. My denominator is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It is. Now let's do the multiplication across the top. 3 times 3 is 9. Let's see if we have 9 shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just decomposed 3/5 into 9/15, and we also modeled it using multiplication right here in a number sentence. All right, so let's take a look at another problem. So let's go into problem number 3. So we're going to jump to the top of the page and take a look at problem number 3. Oh, that's my old paper that I didn't want anymore. Let me get rid of that. Okay, so here we are. We are in problem number 3. And let's go ahead and let's do B. So for problem 3, it says, draw area models to prove that the following number sentences are true. And let me straighten us out a little. Here we go. So for this one, we don't have to show the multiplication. All we have to do is draw the area models. So I'm going to start with my original equation, and I'm going to draw a nice, decently sized model, area model. And the first thing that I have to look at is to see how many pieces make up the whole, or how many parts make up the whole. And the whole is made up of 5 parts. So I'm going to go ahead and draw that. I always like to start with the middle part when I have an odd number of parts. And that's pretty good. So now we have to figure out how many are shaded. And again, the numerator shows how many pieces you have or how many pieces are shaded. So for this one, we have to shade in 2. So right now I have 2/5 of the whole thing. Now I have to show 4/10. I have to cut this up into pieces to make tenths. So again, I can kind of take a look and see, well, how do I turn that 5 into 10? 5 times some number is equal to 10, or 10 divided by 5 will give me that number. And when I do that, I can think 2. So if I have to cut this up into 2 pieces, I just have to cut it 1 time. So this is where I'm going to put my line. And now what we just did was we turned this into tenths. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, that's my denominator. And I have 1, 2, 3, 4 pieces, and that's my numerator. So we just showed how 2/5 is the same thing, or is equivalent to 4/10. All right. So part of your homework is going to be to do the other 3 problems in this set. So now let's go ahead and let's take a look at problem number 4. So now in problem number 4, we are no longer going to use an area model. We are only going to use multiplication to find an equivalent fraction for each of the fractions below. And what's cool is that we can kind of pick what we want to do for this one. So let's go ahead and start with A. So I'm going to start by writing out what my original fraction is, which is 3/4 or 3/4. And then I'm going to go ahead and I'm going to set up my number sentence. Now I don't know what I'm turning it into yet. I get to pick, but let me go ahead and say that I'm starting with 3/4 and I'm multiplying it times something. And again, remember that as long as you multiply a number by 1, it doesn't really change the number. It's the identity element. Let me just show you that really quick. If I do 2 times 1, it's the same thing as 2. It didn't really change. Or if I multiply 4 times 1, it's still 4. Well, again, if we multiply by a numerator and denominator that are the same thing, we're just multiplying by 1. So let's take a look here. Let's go big. Let's make it 5, and let's see what happens. So I'm going to multiply across. 3 times 5 is 15, and 4 times 5 is 20. And so now what I know is that 3/4 is equivalent to 15/20. Let's try one more. We're going to start with 4/5. And we have to turn that into an equivalent fraction. So first I'm going to write what I'm starting with, then I have to show what I'm doing to it, and then we're going to show what we end up with. So maybe we'll go a little easier on this one. Let's just multiply it by 2/2, or 2/2. And 2/2 is just 1 whole. So we're just multiplying by 1. 4 times 2 is 8, and 5 times 2 is 10. So we just showed that 4/5 is equivalent to 8/10. So we're doing a great job here. And for your homework, you are going to be doing these other 2 on your own. So now I'm just going to show you one more problem. We're going to get started on problem number 5 here. So let me get us set up. And here it says, determine which of the following are true number sentences. Correct those that are false by changing the right-hand side of the number sentence. So what we are going to do is we are going to check to see, are 4/3 and 8/9 equivalent fractions? Do they have the same value? And we're going to do this by using multiplication. So let's go ahead and set that up. So I'm going to go ahead and write 4/3 because that's what we're starting with. And then I'm going to go ahead and set it up the way we've been. But I'm not going to write my second fraction yet because I don't know if this is true or false. I don't know if this is correct. So let's take a look. I don't know if they're equivalent fractions. So I'm going to start with my 4/3 because they said to change the right hand side, so I can't change this left side. I'm going to multiply those. Now if I look over here, you can pick either your numerator or your denominator to test this out. So I'm going to go ahead and pick my denominator for this one. And if I take a look at this, I can see that 3 times some number is going to give me 9. Or again, 9 divided by 3 will tell me what that number is, and it's 3. So I know that what I multiplied by to get from 3 to 9 was 3. So I'm going to write that here. And my rule is, if that's in the denominator, it also goes in the numerator, because 3 over 3 is just 1. So let me go ahead then and test this out. 3 times 3 is 9, and 4 times 3 is 12. Wait a second, here they had 8/9, so this is false. And I'm going to go ahead and write false. So that one was false. It did not work. So let's go ahead and try one more. I'm going to try B. So here we have to see, is 5/4 equivalent to 10/8? So I'm going to start with 5/4. I'm going to set it up, show that, well, I'm not going to write that second equation. Remember what I said before, we don't know. So I'm going to set it up here, 5/4 multiplied by some other number, and let's see where it gets us. So this time I'm going to go ahead and I'm going to try the numerator. So 5 times some number should get me to 10. And if I don't know what that is, I can go ahead and say 10 divided by 5 will tell me what that number is, and that's 2. So I know that was 2. So let's go ahead and multiply the top by 2, the numerator, and the bottom, the denominator, by 2. And when I do that, I get 10. 5 times 2 is 10. 4 times 2 is 8. And look, that matches. So in this case, this is true. So this number sentence is true. These are equivalent fractions, and we did not have to change anything on the right-hand side. So part of your homework is, or schoolwork I should say, is to finish out this problem as well from the problem set. And that is it for today. So we looked at equivalent fractions, how to decompose them to show that they're equivalent fractions. We showed how to make equivalent fractions, and we showed how to use multiplication to prove that fractions are equivalent, or in the case of problem 5, not equivalent. So I hope that that was clear. I hope that you guys are really starting to understand this more, and I will see everyone tomorrow morning in our Google Classroom. Have a great night.